All right, folks, today we're moving on to tangents, still continuing to work with circles. So definition here of what a tangent line is a line that's considered tangent if it intersects a circle at exactly one point, and that point is called the point of tangency. Hopefully you can see from the picture there, little red dot. So we have some theorems that go with it here. If a line is tangent to a circle, then it's perpendicular to the radius drawn to the point of tangency, and then the reverse is true, and obviously that forms a 90-degree angle. We're going to go back to using some of those rules today. If two segments from the same exterior point are tangent to a circle, then they are congruent. You can see that's marked in the third one here. So right here we're just identifying if there's common tangents. Okay. So yes, there are. This is tangent here, and then this and this. So those are your tangent points. This does not have any tangent points. No points on the outside connecting the lines. And these ones here have a couple tangent points. You know, right here is tangent points. Right here, right here. Those are all tangent points where things would land. Another theorem, the line is tangent to a circle if and only if it's perpendicular to the radius. So again, just again, point of tangency, 90-degree angle. Those are the things we're going to get out of that. This one says xy is a radius. Determine whether yz is tangent. So if it's tangent, then this is a 90-degree angle. If this is a 90-degree angle, then Pythagorean theorem should work, which means 14 squared plus 16 squared should equal 21 squared. So again, now once we set that up, you're doing calculator work, and you're checking to see if it's true or not. 14 squared is 196. 16 squared is 256. And 21 squared is 441. So when you add these two together, this gives us 452. Does 452 equal 441? No, it does not. So then your answer is not tangent. Again, if that's a true statement, then Pythagorean theorem has to work. So why does this work? And again, this is the same concept of the last one. The conclusion can be made. A squared plus b squared equals c squared. So Pythagorean theorem would work if you have a tangent line. So in this example here, find the length. It says ED is tangent. So ED is tangent. So you're going to use Pythagorean theorem. So 3 squared plus 4 squared equals x squared. 9 plus 16, 25 equals x squared. Square root, so your x is 5. So again, this time they told you it's tangent, and therefore you use the Pythagorean theorem to get that answer. This one here is a little tougher to take a look at because you're not used to this, but again, it says it is tangent, so that means you have to use Pythagorean theorem. Here's our x, so we have x squared. Here's 24. Remember, this is your 90-degree angle, so this is your 24 here. But now this is the challenging part, is what is the distance or length of that line? It's x plus 16. Where students struggle here is when you multiply x plus 16, so I'll do that here, plus times x plus 16. So if you FOIL, you get x times x, so that's x squared. These are your insides, so 16x. These are your outside over here, another 16x. And then you finalize with 16 times 16. And that's 256. So that's where, and then they combine these two in the middle together. That's where they ended up with that trinomial. So I wanted to make sure that you understood how to do that. Now in order to solve, you would subtract these two out, minus the x squared, minus the x squared. Those eliminate. You have your 32x here. Bring that down. Subtracted this over here to get 320. Finally solve, and you get x to be 10. So that's how you would solve that specific problem there. So now try this one on your own and see how you do here. There's my 90-degree angle. So x squared plus 16x equals, and this is x plus 8. That quantity is squared. So x squared plus the 16 squared is the 256. And x plus 8 times x plus 8 is going to be x squared. There's your middle term, so that's 8x. There's your other middle term, another 8x. And then 8 times 8 is 64. So you combine these two together, you get x squared plus 16x plus 64. Your x squareds cancel. You subtract those out. So you have 16x over here. You subtract the 64 over, and that gives us 192. You divide both sides by 16. Final answer, you get x to be 12. Final answer, x is 12. All right, so taking a look at this one here, it says RS is tangent to that. So again, same concept, but they want this whole distance. That's your diameter. Well, we're going to make this an x and find the radius. So we're going to go x squared. I don't know if we can see that very well. So x squared plus 16 squared equals 20 squared. So again, plug in your values. 16 squared. Again, 256, OX squared plus 256 equals the 400. You subtract that over. So x squared is the 144. Square root both sides, you get x to be 12. So this distance right here is 12. They want that doubled, so y equals 24 ultimately. So we found the radius, and you doubled it to get the diameter. Okay, this one down here says determine whether it is tangent or not. So again, if that's the case, this would be your 90-degree angle. 7 squared plus 9 squared would have to equal 14 squared. 49 plus 81, and 14 squared is 196. Add 81 and 49 gives you 130. 130 does not equal 196, so your answer in this case is no, it is not tangent. If two segments from the same exterior point, then they are congruent if they're tangent. So taking a look here, again, here's your point. It says they are tangent, so you just set these two equal to each other. 5x plus 4 equals 8x minus 17. Give you a chance to solve that one on your own. So if you do, you would get 3x over here. You would add this over to get 21, and you divide and you get that x is 7. Final answer is 7. Couple of questions here on this slide, so just kind of a review of what we're doing here. Again, this would be your 90-degree angle. So 10 squared plus 24 squared. Does that equal, you got to add these two together. Does that equal 26 squared? So we would have 10 squared, 100. 24 squared is 576. 26 squared is 676. 676 equals 676. So yes, that does work. So yes, that is tangent, correct. Okay, so we want to find x and y. So in this case, these two are equal because again, they're going to a tangent point right here. So y equals 10. So over here, we're going to plug in. So 10 minus 5, this section here is 5. Okay, so if you were to actually add this up, you would have over here, you would have 10 plus 5, so this would be 15 on the left. On the right, we have 10 plus that, so that'd be x plus 14. And then you subtract over and you get x equals 1. Final answer would be x equals 1. This right here is a definition here. Polygons can be circumscribed about a circle, or the circle is inscribed in the polygon. So again, take a look at where your vertices are, where they line up, and how that works. And then again, we're using the same concept that we just did in the last one. So here's our point. This is our tangency. So if this is 16, this is 16. Same thing here. From here to here is 18. Here to here is 18. And then this right here says NK. So here's NK equals JL. So here's JL is 16 plus 29. What's 16 plus 29? That should be 45. So this section is 45. This section is 45. Add up all of the numbers going around the outside, and you find that your perimeter is 158 units. So perimeter equals 158 units. Add up all those numbers going around the outside. Last question here, folks, same idea. If this is 6, this is also 6. If the whole thing is 16, that makes this 10 and this 10. If this is 12, this is 12. Add up all those numbers that I added plus the ones that were already there. Final answer is D, 56. Great